another session. I'm your Vitema, as usual, virtual teacher of mathematics, Bueno Evans. I have always said that you're free to contact me at any time, 0714-890-190, 0714-890-190. In this session, we shall be looking at a topic in Form 2, indices. I want us to consider the following. Given 2q, also known as 2 to the power 3, this is supposed to be 2 times 2 times 2, which gives us 8. I want you to take note that 2 to the power 3 is not 2 times 3. It is 2 multiplied by itself 3 times. There is often that confusion. Read cube. I've given many learners and they give me 9. That is wrong. It is 3 times 3 times 3. That should give me 27. In the same manner, 5 squared should be 5 times 5. That should give us 25. Finally, for now, if I give you 5 to the power 4, that should give us 5 by 5 by 5 by 5 should give me 625. Take note again, 5 to the power 4 is not 5 times 4, so it will not be 20. The correct answer is 625. There are terms that I want to introduce. Two power 3 equals to 8. In mathematical terms, 2 will be known as the base, 3 will be known as the index. The plural of index is what we call indices. In other words, we are going to... There are terms I want to introduce. If 2 power 3 equals to 8, 2 is known as the base, 3 is known as the index. When you have more than one index, you end up with indices. In other words, indices is the plural of index. When you have the second one, we gave us 5 squared equals to 25. 5 will be the base, 2 will be the index. In the same manner, should I give you 6 cubed to be 216? Again, 6 becomes our base, and then 3 becomes our index. So those are the technical terms that we'll be using from time to time. So know which one is the base and which one is the index. Of indices. These are rules or guidelines that we use when operating on indices. I did say when we talk about operations in maths, we shall be talking about how do I add, how do I subtract, how do I multiply, and how do I divide. There are certain rules that we must take into consideration if we have to work on indices. Law number 1, some people call it the law of multiplication, others call it the law of addition. But this is what it says. I'll be giving and then giving an example. Law number 1 says that at all times, a to the power n times a to the power n equals to a to the power n plus n. This law is saying that if you happen to be multiplying numbers of the same base, the bases must be the same, but of different indices, all you need to do is to add their indices. I'm going to give an example. If I gave you 3 squared times 3 to the power 4, according to this law, you can already see that the bases are the same. So all you need to do is to say 3 to the power 2 plus 4, which equals to 3 to the power 6. And it is very easy to demonstrate that. What does 3 square mean? 3 times 3. Then multiply. What does 3 to the power 4 mean? 3, 1, 2, 3, 4. Even if you did a simple count, it is going to be 3, 1, 2, 3, 4, 5, 6. That is why we are saying that 3 squared by 3 to the power 4 is simply 3 to the power 2 plus 4. That gives us 3 to the power 6. So that is the first law of indices. The law of addition, if you like, the law of multiplication, depending on whether are you talking about the index or are you talking about the base. Law number 2, this is very crucial. I want to call it the mother law, because out of this law we are going to get another 3 or so other laws. The law of of subtraction of the indices. The law of subtraction of the indices. This one says that at all time a to the power m divided by a to the power m should give you a to the power m minus n. In other words, if you are dividing numbers of the same base but different indices, all you need to do is to take away their indices. An example again, that if you have 5 to the power 4 divided by 5 to the power 2, this one should give you 5 to the power 4 minus 2, which is 5 squared. We want to prove it, or rather demonstrate it very easily. What does 5 to the power 4 mean? It is 5, 1, 2, 3, 4. Divided by 5 by 5. You are aware that 5 divided by here means you can put it over, because that will explain it easier. So that means we'll have 5, 1, 2, 3, 4 over 1, 2. So what is going to happen? It will cancel. Another 5 will cancel another what? 5. So what do we have at the end of the day? 5 times 5 over 1 times 1, which is going to be 5 squared, which is 25. So this one is a mother law. Anytime you are doing a division of numbers of the same base, you simply take away their indices. That is our law number 2, and I am calling it a mother law because the next 2 laws are based on this particular law. So I want us to go to law number 3. I call it the mother law. Why am I calling it a mother law? Because out of law number 2, we are going to have about 2 other laws from it. The law of division of the bases, or the law of take away when it comes to the indices. This law states that a to the power m divided by a to the power n, that one should give us a to the power m minus n. I use numbers to explain. If I have 5 to the power 4 divided by 5 to the power 2, the bases are the same. This law tells me it is 5 to the power 4 minus 2, which is 5 to the power 2. Can we show whether this works or not? What does 5 to the power 4 mean? It is 5, 1, 2, 3, 4. Divided by 1, 2. As we are aware, division means over. I want to use that method because it will show it very clearly. 5, 1, 2, 3, 4 over 5 by 5. So what is going to happen? We'll cancel up and down. What do we remain with? We have 5 by 5 over 1 times 1, that gives us 5 to the power 2. Exactly what we had at the beginning. I'll give another example. If I have maybe 3 to the power 4 divided by 3 to the power 3, we are saying this is 3 to the power 4 minus 3, which is 3 to the power 1. How do we show that this is true? I'll go straight away to numerator and denominator. That means in our numerator we will have 3, 1, 2, 3, 4. In our denominator we will have 3, 1, 2, 3. So we will cancel 1, 2, 3. We will remain with 3 over 1, which is 3 to the power 1. Exactly that. So that is what we call our law of the division of the bases, or the law of takeaway when it comes to the indices. It is a very important law because it is going to give us 2 other important laws. Next law is a very interesting one. The zero index. Very interesting. Anything to the power 0 will be 1. Anything. What does that mean? If I told you 5 to the power 0, the answer is 1. If I tell you 15 to the power 0, the answer is 1. K to the power 0, the answer is 1. 1024 to the power 0, the answer is 1. We want to see how that comes about. I told you that law number 2 is our mother law. So let me demonstrate. Suppose I'm given 5 cubed divided by 5 cubed. According to law number 2, this is going to be 5 to the power 3 minus 3, which is 5 to the power 0. I'm saying this is 1. Let us prove it. 5, 1, 2, 3 over 5, 1, 2, 3. So what are we doing? 1, 1, 1, 1, 1. We now have 1 times 1 times 1 over 1 times 1 times 1, which gives us what? 1. Let's give another example. 6 squared divided by 6 squared. According to law number 2, 6, 2 minus 2, 6 to the power 0. We are saying same person.
Sijui nimeileta. Nimeileta hiyo imeandikwa. Mbona na tuendelee?
Another example could be 6 squared divided by 6 squared. According to law number 2, it's going to be 6 to the power 2 minus 2, which is 6 to the power 0. I am saying this is 1. How comes? 6 by 6 for the first one, 6 by 6 for the second one. The first will cancel the second, 1 each, 1 times 1 over 1 times 1, the answer is 1. What does that mean? Anytime you have a number raised to the power 0, come on 15, 10 to the power 0, I am telling you to take the number and divide by itself. Even if you are given k to the power 0, take k over k, it will give you 1. Even if you are given 123 to the power 0, at all times remember it is 1. Even if you are given 3 to the power 0, at all times remember it is 1. This is going to be very important later on when we deal with the logarithms. There is why it's not applied. The negative index. If I gave you 7 to the power negative 2, what exactly does it mean? It will mean 1 over 7 squared, which is 1 over 49. This also arises from law number 2. How does it come about? Assuming I gave you 7 to the power 3 divided by 7 to the power 5. According to law number 2, 7 to the power 3 minus 5, which is 7 to the power negative 2. So let us see the meaning of this. The first one is 7, 3 of them. The second one is 1, 2, 3, 4, 5. So what do you have? The first bingo, the second set, and the third set. What do you remain with? 1 above, 7 times 7 below, 1 over 7 squared, which is 1 over 49. Another example. If I gave you 5 to the power negative 3, I am saying this one is 1 over 5 cubed, which is 1 over 155. How comes? Suppose I gave you 5 to the power 1, divided by 5 to the power 4, should be 5 to the power 1 minus 4, which is 5 to the power negative 3. So let's come to that. The first one is just 1 5 above. The second one is 4 of them. 1, 2, 3, 4. So the first will cancel 1. You will remain with 1 over 5 by 5 by 5, which gives us 1 over 5 cubed, 1 over 155. In other words, always remember that anytime I am given a negative power, I get 1 over the reciprocal. You just get the reciprocal of the number, then the power becomes positive. 5 to the power negative 3 becomes 1 over 5 cubed. It is an area that also confuses students a lot. The final one I want to go for is what is known as the fractional index. What does it mean? Index. That is the last one before we come to computations. The fractional index. What does it mean? If I gave you 125 to the power of 3, what exactly am I telling you? I call this one the roots. It simply means the cube root of 125. In other words, give me a number that when I multiply by itself 3 times, I will get 125. Our answer here will be 5. If I told you 16 to the power a half, I'm talking about the square root of 16. As you know, this one will be 4. If I told you, what about 216, as I'm saying, to the power a third, I'll come to that later, 1 over 3. That one will give me which number? It tells me, get me the cube root of 216, you'll be able to get it to be 6. So the fractional index simply means the root of the same. So with that, I will then now take us through sample computations or calculations that you may be asked to do in application of the laws of indices. So that's what I want us to go through. What are some of the questions, what are some of the things that I may ask so that I apply my knowledge of the laws of indices? I want to start with a simple direct one. I may ask you to evaluate 512 to the power 2 over 3. Then you're wondering, how do I move it? It's advisable to start with the denominator of the index. Split it into 2. In other words, work it out as 512 to the power a third. After that, you square. That's the best way to go about it. Start with the denominator first of the index. What does that imply? It's going to be the cube root of 512. After getting that cube root, you square it. That will be, if you check, it will be 8 that will be the cube. 8 times 8 times 8 will give you 512. If you square that, you get 64. So that would be one. Another one, I may ask you, what about 625 to the power 3 over 4? As I said, always begin below. So this one is going to be the fourth root of 625. After that, can you cube it? If you check, you will get the answer is 5 for 625, the fourth root, and then you cube it, that will give you 125. So that is how to go about the fractional indices when you are being told to manipulate them. Laws of indices application. Another example, and this is crucial because a number of questions revolve around this time. You will be told, for example, work out the value of t. What is the value of t if 2 to the power t minus 3 times 8 to the power t plus 2 equals to 128? This is a typical question you will be asked. The first thing you need to check is it multiplication, division, or addition and subtraction? This sign here is very important. Because if it is multiplication and division, it's a bit more direct. So in this case, what we do is we look for a common base. That is what we do. Just look for a common base. A number, a base that can be used in all of them. Here our base is going to be 2. In other words, 2 will remain 2 to the power 1 into t minus 3. For 8, for you to get 8, it will be 2 cubed to the power t plus 2. And I believe this other one is going to be 2 to the power 7, if I'm not wrong. I believe so. 128 is supposed to be 2 to the power 7. So because we are dealing with the laws of indices, where there is multiplication, we will replace it with addition, law number 1. So drop, do not cancel. Drop the bases. Deal with the indices alone because you've already made the bases the same. What does that mean? Now we have t minus 3. Instead of multiplication, it will be plus 3t plus 6 to give us 7. We are only dealing with indices here. Then now we put the like terms together, t plus 3t minus 3 plus 6 equals to 7. So we'll have 4t plus 3 equals to 7. 4t plus 3 minus 3 equals to 7 minus 3. 4t equals to 4, and therefore t equals to 1. T will be 1 at the end of the day. So, suppose I'm given to find k, and then you are told that 3 to the power 2 minus k times 27 to the power k plus 1 equals to 729. 729. As I did say, you check. Do I have multiplication and division or plus and minus? If it is multiplication and division, your work is easy. You only look for a common base. So here, our common base, in many cases the common base is the smallest number or the smallest integer you see. So the first one is 3 to the power 1 into 2 minus k, because 3 to the power 1 means 3, times 3 cubed into k plus 1 should begin to give us 729. That one should be 3 to the power 6, I believe, if I'm not wrong. 729. My mind is telling me that one should be 3 to the power 6. I think so. So it will be 3 to the power 6. Now that I've written everything under the same base, I drop the bases. Do not cancel, just drop them and deal with the indices. Now I have 2 minus k. Because of multiplication, it becomes plus 3k plus 3 to give us 6. Like comes together, 2 plus 3 minus k plus 3k to give us 6. So 5 plus 2k to give us 6. And therefore 2k will be 6 minus 5, that is 1. We end up with k equals to a half. So suppose this one was a division, then instead of addition, you will have subtraction. That is the only change that is going to be there. I will now take you slowly through one where instead of multiplication or division, we have a plus or minus. This one we need to be very good. Okay, let us look at one where we do not necessarily have multiplication. We are supposed to have find x if 25 to the power x minus 1 plus 5 to the power 2x equals to 1/3. If you look at this one, we are not multiplying the bases. Neither are we dividing the bases. We are adding them. For this one, we will begin with one what I call expansion. And you begin how I'm going to expand. Step 1, I want us to expand. What do I mean by expand? This one will be 25 to the power x. Because of this minus, it will be divided by 25 to the power 1. That is the meaning. Or take away. Then plus 5 to the power 2x to give us 1/3. That is step 1. After expanding, what you now need to do is now identify a common base for the numbers with x. You do not need to struggle to get a common base for this one. It is not necessary. I will write this 25 as 5 squared x, their power, over 25 plus 5 to the power 2x equals to what? 1/3. If you look at this scheme, we have created some common factor here, or some common expression here. Next, you do what is called substitution. For example, you say let 5 to the power 2x be equals to p. What does that lead me to? It leads me to the upper one will be p over 25 plus p over 1 to give me what? 1/3. That is what it will lead me to. I can then multiply everything by 25 so that I eliminate the denominator. If I multiply this by 25, I will remain with p. Plus, if I multiply this by 25, I'll have 25 what? P equals to 130 times what? 25. Everything by 25. So that this will be a total of 26 what? P should give me a total of 130 times 25. Let me just have it as 130 times 25. I don't want to struggle so much. Then I divide both sides by 26 and both sides by 26. I can see 26, 130, that should be around 5. So that our P is supposed to be this one, this is 5. 5 times 25, which is 100 and what? 125. That is what it's supposed to be. Okay, let me give another example to explain how to work when we have addition and subtraction. Suppose I want you to find x, in which 125 to the power x plus 1 plus 5 to the power 3x equals to 130. We are adding the bases, we are not multiplying. So do not struggle to have a common base for all of them. Instead, begin by expanding where the indices need you to do that. So what do I mean? I have 125 to the power x. Because of addition of the bases, it will be times 125 to the power 1 plus 5 to the power 3x equals to 130. It is after the expansion that I now look for a common base for the numbers with x in their index. I can see that 125, I can write it as 5 cubed, then there is an x, times 125 plus 5 to the power 3x will give me 130. I want to substitute with the letter P 5 to the power 3x because I can see it more than once. So what does that give me? I have my first P for 5 to the power 3x times 125 plus P, that is the second one, to give me 130. So that means I have 125P plus another P to give me 130. A total of 126P to give me, sorry, we have to repeat it to 630. Look at another example on where we are not multiplying the bases, but instead we are adding them. 125 to the power x plus 1 plus 5 to the power 3x equals to 630. These people want us to find x. So how do I go about it? Because we are not multiplying, we are not dividing the bases, we will begin by expanding. What do I mean by expanding? 125 to the power x. Because of this plus, it will be times 125 to the power 1, then plus 5 to the power 3x equals to 630. I've already done my expansion. Next, what do I do? I will now use a common base only for the numbers with an x and an index. Don't struggle with the rest. That means we now have this as 5 cubed x times 125 plus 5 to the power 3x to give us 630. I can see I've created some common number there. I want to let my 5 to the power 3x be equals to p. What does that lead me to? I have my first p times 125 plus my second p to give me 630. 125p plus another p to give me 630. A total of 126p to give me 630. And therefore my p, if I divide both sides by 126, will be able to give me 630 over 126, and therefore my p, I guess, should be 5 at the end of the day. So mathematics You don't get it by listening. You get it by taking time to practice. You need to have a lot of questions to practice. Some will challenge you, some will be direct, some will be easy. The more you do, the better for you. So I would suggest that you look for a number of questions in this topic, work them through, and confirm from any source that you're right. Thank you once more, as I've said, I'm your teacher, virtual teacher of mathematics, Bueno Evans. If you have any questions, queries, or suggestions, call the number. Then we can be able to work together. 0714-890-190 is my number. Wish to meet you in our next session. In question, it's actually a simultaneous equation in both the indices. So one is telling us, solve the simultaneous equation below. So the first part is 5 to the power x times 5 to the power 2y equals to 25. The second part is 3 to the power 2x times 3 to the power 1 equals to the cube root of 81. Looks difficult, it is not. For the first part, whenever we are multiplying or dividing the bases, put everything under the same base. So for the first one, we write it as 5 to the power x times 5 to the power 2y equals to 5 squared. I think you can see that. What does that mean? We drop the bases and we remain with x plus 2y equals to 2 as our equation number 1. That's what they needed. Let's go to part 2. We've been given 3 to the power 2x times 3 to the power y equals to cube root of 81. So the first thing you must ask yourself, what is the cube root of 81? I'm not very sure whether they gave us the right thing. I'm suspecting this one was supposed to be the fourth root of 81. So allow me, using my knowledge, to change it so that we see how it goes like. So that now we have 3 to the power 2x times 3 to the power y equals to the fourth root of what? 81. So what does that give us now? 3 to the power 2x times 3 to the power y equals to 3. Because the fourth root of 81 is 3, and you can write it as 3 to the power 1. So, are you seeing now the bases are the same? Now that the bases are the same, now we can have it as 2x plus y equals to, as our equation 2. And therefore, we now have x plus 2y equals to 2, and 2x plus 2x plus y equals to what? 1.